Good morning. Thank you for joining us live from NASA's Kennedy Space Center in Florida. I'm Cheryl Warner in the Office of Communications. Today, NASA's commercial cargo provider, SpaceX, is here to discuss its 13th Commercial Resupply Services mission to the International Space Station. Launch is targeted for no earlier than December 12th at 11:46 a.m. NASA is using the International Space Station to conduct cutting-edge research and technology development to help prepare our astronauts to take the next giant leap in human exploration. Packed with more than 4,800 pounds of research, crew supplies, and hardware, the SpaceXDragon spacecraft will launch from Space Launch Complex 40 at Cape Canaveral Air Force Station in Florida. Here to discuss today's launch, our program manager, Kirk Shireman, joining us live from NASA's Johnson Space Center. Jessica Jensen, Director, Dragon Mission Management at SpaceX. Kurt Costello, Deputy Chief Scientist, ISS Program Science Office at NASA's Johnson Space Center. And Lieutenant David Myers, Launch Weather Officer, 45th Weather Squadron. Each of our participants will provide brief remarks before we take questions. We'll begin with questions in the room. For those on the phone line, if you'd like to submit a question, please enter the queue at any time by using *1 on your phone. And we'll also take questions online using the hashtag AskNASA. Kirk, we'll begin with remarks from you.
All right, good morning. Thank you. It's a pleasure to be here. I look very much forward to the launch of SpaceX-13 tomorrow. And really, this is the initiation of a busy week on board the International Space Station. So I wanted to give you a few highlights. So tomorrow we launch SpaceX-13, but this is actually not the first activity on orbit this week. So the first activity will actually be the undocking and deorbit of the 51st Soyuz on Thursday the 14th. So we're looking forward to a safe return of the Soyuz on Thursday. And in fact, our teams are on the ground. Our Russian and U.S. teams are on the ground in Kazakhstan right now as we speak, and preparing to execute the landing operations there on the ground. On the 15th, on Friday the 15th, we expect the Dragon to berth to ISS. So we'll take a breather, and then on Sunday, we'll have the 53 Soyuz launch with Tingle, Kenai, and Shkaplerov out of Kazakhstan, out of Baikonur Cosmodrome. And the docking will be 2 days later on the 19th. We cap off the year, the very next day, with a high solar beta period, which will extend to the 25th. In the high solar beta or high solar angle regime, basically the ISS doesn't see a sunset or a sunrise. It's basically one long day, and it puts a lot of thermal constraints on the vehicle, so we try to avoid critical operations, dynamic operations like spacewalks and vehicle dockings and undockings during this high solar beta. So we're looking forward to a busy week, followed by maybe a little breather during the high solar beta period. One other activity that's going to go on orbit is we're going to deal, the ISS crew, we've already unberthed and let go of the Cygnus vehicle, but actually it will re-enter the Earth's atmosphere on Friday. So a lot of space station activities this week. So in 2018, a busy year. Just touch a few highlights for that. Of course, research will be ongoing hot and heavy with the SpaceX-13 Dragon mission. We have 2 spacewalks planned for January, really to position ourselves for the replacing of a latching end effector that's anomalous on the ISS, and we'll conduct those and be ready to return that latching end effector later on in the year on a future Dragon flight. We have 3 progresses, 4 Soyuzes. We have a number of SpaceX Dragon and Cygnus flights, and in addition, we'll be preparing for on orbit for the commercial crew flights that year. So really 2018, a very pivotal year, very busy year, and we'll look forward to talking to you more about that as the year progresses. But for right now, we're all focused on SpaceX-13, on Dragon and Falcon 9, and looking forward to a successful launch and a mission starting tomorrow. With that, I'll handle it back to you, Cheryl.
Thank you, Kirk. And now we'll hear from Jessica.
Good morning, everyone. So first, I want to give a huge thanks to NASA, the Air Force, and the FAA. Particularly NASA as our customer. They have provided us a tremendous amount of support, hard work, and flexibility especially as Kirk said, in launching during this very busy time. NASA's been our partner through activation of the Launch Complex 40, as well as for the reflown booster and the reflown Dragon that are be flying on this mission. It's the first time we're doing the two of those together. So NASA's been a great partner in helping us with qualifying that hardware, as well as we've been provided a ton of guidance from the FAA and the Air Force as well. So I really just want to thank all three of them, because without them, this mission wouldn't be possible tomorrow. So I think people covered some of the basic facts. Launch tomorrow at 11:46 a.m. We will be berthing very early Friday morning. This is the 13th of 20 missions on the current cargo resupply services contract. After that, SpaceX has been selected for to do continued cargo resupply into 2024. So we're looking forward to a very long time of sending supplies to and from the International Space Station. So this is going to be the first launch out of Launch Complex 40 since 2016. And instead of just rebuilding the pad as it was, we wanted to modernize it. So, basically, we wanted to take a 10-year-old pad and make it high tech. So one example is 10 years ago, I was at SpaceX. I was a vibration engineer, and I was actually doing some of the electrical wiring for vibration sensors on the transporter erector. And I'm pretty sure there are people that are much better at that now, and we have much better systems to do that. So that's part of our modernization effort. One of the biggest things we want to do is increase the automation on the launch pad. So we have a significant amount more of sensors than we had from 10 years ago, and a lot more computer control of the systems on the launch pad. And what that means is we have a launch pad that can do launch to launch in a faster turnaround time, as well as a much more reliable pad for safer missions. So we're excited for the Pad 40 upgrades and seeing them in action tomorrow. The first stage, so tomorrow after stage separation, the first stage is going to head back to Landing Zone 1 at Cape Canaveral Air Force Station. And if it's successful, this will be the 20th recovery of a Falcon booster. And it's going to be the 14th this year. So we're very excited for that. As I mentioned, we are going to be reflying the booster from CRS-11. So this booster supported the CRS-11 mission in June of this year, and this Dragon capsule supported the CRS-6 mission back in 2015. So we have those coming together now to bring you the SpaceX-13 mission. This is going to be the fourth time we are reflying a booster for one of our customers, and the second time that we are reflying a Dragon. And really what this is this is the beginning of rapid and reliable reusability. And basically, even though we're spending a lot of time now doing additional testing on hardware, additional inspections, working very closely with NASA, in the long run, reusability is going to significantly reduce the cost of access to space. And that's what is going to be required to send future generations to explore the universe. We want to be able to send thousands of people into space, not just tens. And so reusability is a very key part of that, and we're excited because tomorrow is just, one step closer to that. With that, again, just, thanks again to all of our partners. Back to you.
Thank you, Jessica. And now we'll hear about some of the science from Kurt.
Thank you, Cheryl. It's great to be here today. SpaceX-13, the CRS mission, is bringing science to space station that is going to access the unique capabilities of this one-of-a-kind laboratory that we have on orbit. In orbit, we have microgravity conditions that allow us to investigate the impacts on biological life and fluid flows. We also have exposure to space radiation and access to unique views of the Earth, both down on the Earth and into space. The experiments flying on SpaceX CRS-13 will be joining some of the 329 experiments we have ongoing during increment 5354, bringing us to date up to 2,465 experiments and over 1,400 publications that have come from space station research. SpaceX-13 is big on biology, and let me explain that. Plant growth, one of the areas that we do research into on space station, has 8 investigations flying on the SpaceXDragon, and they spread out over multiple different facilities we have on orbit. In the Tango Lab Cube Labs, we have investigations looking at microclover and Arabidopsis, In the BRIC, the biological research in canisters, we're flying a new LED unit to increase plant growth results in that facility. We're also flying the first of its kind research in the EMCS, plant gravity perception. This investigation is advanced in the way that it's going to look at plant responses to partial gravity loading. So how plants may develop on Earth, on the Moon, in zero gravity, and maybe even on Mars. When we move over to cell science, we also have new facilities coming online. The bioculture system, or the BIOS facility, is going to be growing 2 different cell types as pathfinders and validation testing for a system that will allow us to bring cells and small tissues to orbit and grow them on orbit. We also have the STARS Bioscience facility going up. This facility is going to be growing thyroid carcinoma cells and also Staphylococcus aureus in an opportunity to see how these organisms adapt to the microgravity environment. Beyond cell science, we have amoebas, bacteria, and mice. Oh my. More organisms than you could think are stacked in the Dragon right now and awaiting launch. On the physical sciences side, we also have a number of investigations going on in the realm of physical sciences and tech demos. Made in Space is flying their space fiber optics facility, which will be looking at the creation of Z-band fiber optics in space. We have protein crystal growth experiments going on from both JAXA and the United States, where we'll be looking at using the microgravity environment to develop more slowly and larger and better crystals for use in pharmaceutical therapies on Earth. In the area of colloids research, we'll be doing self-assembly, as we'll be taking advantage of the fact that things don't settle out on orbit in microgravity. That slow progression allows us to study forces like self-assembly and understand how we can use that in chemical and product development here on the Earth. And finally, we'll be looking at implantable medical devices for a number of things, both for drug delivery systems and actually for sensor systems for being able to monitor glucose in patients here on Earth. And then finally, we have an external trunk on Dragon, and we've got 2 major payloads going up. TSIS, the Total Solar Irradiance Sensor, and Space Debris Sensor. TSIS will be looking at the overall energy output of the sun and using that input to feed models for environmental controls here on Earth, environmental monitoring here on Earth, and to understand the energy balance, whether or not we're taking in as much energy as we're putting out, or what that difference leads us to. The Space Debris System, SDS, is looking at the space debris environment in low Earth orbit. We know very little about smaller debris fields. We can map down to about 5 centimeters, but smaller than that, it gets difficult to map. So looking at the direction, the mass, and the velocity of all of those space debris hits on the SDS will help us better characterize that environment, hopefully so that the commercial market can operate more safely in that arena. So with that, I'd like to roll over to our National Lab video. We have a video that details a few more of the investigations that we have going on.
Hi, I'm Patrick O'Neill, and we're here at Made in Space, the innovative company that is responsible for having the 3D printers on board the space station. Now the startup is focused on bringing fiber optic technology to the space station. In validating this new form of technology on the ISS, it can open channels to exciting endeavors like on-orbit manufacturing in low Earth orbit. Here are some of the other major payloads launching to the ISS National Lab on this mission. A startup company, BioRacis, seeks to use the microgravity environment of the space station to improve the accuracy of wireless, medically implantable glucose biosensors for day-to-day diabetes management. Budweiser will be sending 2 separate experiments in hopes of looking at gene expression and germination within barley. Studying barley in microgravity may reveal new information on the germination process. The Houston Methodist Research Institute is partnering with pharmaceutical leader Novartis on a rodent research investigation to evaluate the efficacy of an implantable drug delivery system that could assist those with muscle atrophy on Earth. Launchpad Medical will send a synthetic bone material capable of adhering bone to metal within minutes to accelerate repair. This is an ideal environment to evaluate the healing response and development of effective treatments for patients needing bone repair. This launch brings a culmination to an incredible year of research on board the ISS National Laboratory in 2017, and we thank our partners at NASA, SpaceX, and Orbital ATK. I cannot wait to see what happens on the space station in 2018 and beyond.
Thank you.
Thank you, Kurt. And now we're here for a weather update from Lieutenant Myers.
Thank you, Cheryl. For our weather, we're expecting generally clear conditions. Winds will be a little bit high, but they've been high since that front went through this past Saturday. We are going to see a trough swing through on Tuesday, really into Tuesday early afternoon, and that trough could increase our winds, and it's also going to increase winds on Wednesday, the backup opportunity. If I could go to my first slide, please. So for our main forecast here, our winds are going to be 15 to 19 knots at about 200 feet. Temperature will be about 65 degrees right there at about T0. Concerns are liftoff winds, and our probability of violation is only 10% right now. For our backup opportunity, expecting winds to be about the same. Overnight, they'll increase and then drop as we go into the morning hours on Wednesday. So 15 to 19 knots again at about 200 feet. Temperature is going to be about 58 degrees, so a little bit cooler on Wednesday. And our concerns are still going to be those liftoff winds with a probability of violation of 20%. Now, another thing I'd like to point out, if we could go to my next slide, please. As that trough dips down, the chart you're seeing there is a jet stream chart. So that's at about 40,000 feet, and those colors are indicating increased winds. So that deep purple are winds over 130 knots. So what we're seeing is that dropping down with our trough, and that is going to increase those upper level winds. That is a concern for Falcon 9 launches, but it is not something the Weather Squadron will actively evaluate on launch day. Our weather balloons will send that data to the customer, and they make their decision from there. Thank you.
Thank you, Lieutenant Myers. With that, we will open it up for questions. Again, we'll begin with questions in the room. If you're on the phone line, please press *1 to enter the queue. And if you have questions online, please use the hashtag AskNASA. Our first question, please, from Marcia Dunn. Oh, yes.
Yes, I did. Marcia Dunn, Associated Press for Kirk, if I might. Do you expect your anxiety level to be slightly higher tomorrow, given that this is a reused rocket that you'll be using for the first time at NASA? And also, am I safe to presume that there will be Christmas presents on board?
Well, let's see. I cannot confirm nor deny the presence of Christmas presents. I guess I could say that on board the Dragon. Seriously, I don't know. There are crew care packages, and as program manager, I don't have to go inspect all those. So it wouldn't surprise me, but I can't say for certain. As for the anxiety level, you know, I've been in this business for a long time. Every time we launch a rocket, I'm anxious. It's still a dangerous business, and so I will be anxious tomorrow. I can tell you a number of things. First off, you know, reusability. The shuttle was a reuse. We reused the boosters. We reused the main engines, and so the notion of reusability is not new. We did an extensive review, and by we I mean the entire agency. We engaged rocket experts from around the agency to define not only first off define what NASA would like to see in terms of data and analysis and testing and even inspection in between the flights. Then we met with SpaceX and reviewed what they did, and we're very comfortable that the risk posture on this vehicle is not significantly greater than a new booster. The way we look at it is we've retired some risks, or some risks are actually less on a reflown booster, and some risks are actually a little greater, and the net result is about equivalent risk. So we think of it as equivalent risk. Which is not to say zero risk. So yes, we'll be anxious, but I wouldn't say a higher level of anxiety for this reflown booster than a new booster.
Thank you. Next question from Bill Harwood.
Well, just to kind of, Bill Harwood, CBS News for Jessica, I think. Just kind of following that up, give us some sense of what you guys do to a used booster to get it ready for flight. Does this have the same 9 engines on board? Have you swapped out engines? What do you have to swap out? What do you do that's in general or different than you do for a new booster?
Sure thing. So the biggest thing is ensuring that all the hardware is qualified for multiple flights. And so basically we do that with test units that are built to the same flight specification as the flight hardware and make sure that those can go through multiple life cycles. So for example, we will take one of our engines and fire it in Texas over and over and over again to simulate multiple flights. In between flights, the goal is to not swap out hardware. Basically, every piece of hardware has a service lifetime based on that testing I just talked about. And if it's still within its service lifetime, we verified that all the environments on the previous flight were good, then you can just continue to reuse it. So we do, in between flights, do very thorough inspections. So we want to make sure that something off-nominal didn't happen on the previous flight. So we go through, we look at critical areas, we inspect welds, but we do not generally replace engines. If we need to, we can do that, but in general, we do not do that. So it's mostly just inspecting everything and making sure we're good to go. One of the other things we do is, we bring, our stages go to Texas prior to each mission where we do a stage firing. And after that, we do a series of pressure tests and all kinds of avionics checkouts on the vehicle afterwards. We do that same set of tests now after each flight. And what that is gives us high confidence that moving into the mission, like Kirk said, we're at basically an equivalent level of risk as we were on the first flight.
Next question from Irene, please.
Hi, Irene Klotz with Aviation Week for Jessica. Are there any plans to refly any of the current first stages or Dragon capsules more than twice? Or will that wait for the Block 5 and Dragon 2? And do you have an approximation of when Block 5 might be flown for the first time?
Yeah,
Thanks.
sure. So to answer the first part of your question, like I said, everything has a service lifetime. So Dragons and Falcons, depending on where they are and what the service lifetime is for that specific unit, can fly more than twice. So we do have plans to fly more than twice in the future. And the first Block 5 flight is targeted for early next year.
Question from Ken, please.
Hi, Ken Kramer, Universe Today. For Jessica, thank you. You went through the Falcon 9 refurbishment. Can you go through the Dragon refurbishments? And are you going to build any new Dragons? And for the Lieutenant, can you describe what are the wind constraints on the ground as well as the upper level winds that you expressed concern about? Thanks.
Yep. So the reflight process for a Dragon is very similar to Falcon in that you have to qualify each component for multiple flights, and then when Dragon comes back, we do a very thorough inspection of it. So one of the main things we have to do is the thermal protection system on the outside, called the TPS, all those tiles you see in the heat shield. That does have to currently be replaced each mission, but most of the hardware inside goes through an inspection, and it's usually good for the next flight, provided that all of its thermal and vibration environments were within specification. So that's basically the process for a Dragon vehicle. For the remainder of the current CRS contract, we are planning to continue to just use refurbished Dragons. We have enough in our fleet to continue to use refurbished Dragons for the rest of the current CRS contract.
Question from James, please.
The winds.
He had asked a second question
Sorry.
on the winds. So for the winds, I can't specifically tell you what the specific constraint is. They are dependent on direction and the structure. It is a user constraint, so it is something that SpaceX has asked us to monitor and alert them if they exceed those constraints, and we'll do that all the way through the count.
Now a question from James.
Thanks. James Dean, Florida Today for Kirk Shireman. Could you clarify how many launch attempts do you expect to have with the cutout and Soyuz activity coming up? And regarding reuse, do you also see this as important to the future of spaceflight, to reducing costs, the things Jessica mentioned earlier, or are you really just doing it because SpaceX wants to and you verified their data looks good?
Launch attempt. I expect to launch on that attempt. So, however, having been in this business a long time, I understand things can happen. So we have a launch attempt on the 12th. We have another launch attempt, a capability from an ISS perspective on the 13th. And then our final one prior to this beta cutout is actually on the 15th. So really we have, from an ISS perspective, we have three launch attempts before the big high solar beta region I was talking about. And then the next attempt in terms of ballistics really picks up around the 25th of December. So we are looking at that because we thrive on being ahead of the game, but we're optimistic that we'll get off on the 12th or 13th, and we'll see how things play out. As for reuse, I think there's no question that reusability, especially reusability without a tremendous amount of hardware replacement, can change the economics of launch. And the reality is that the business of space is dominated by launch costs. Certainly in the human spaceflight world, it's dominated by launch costs. So getting the cost down is important for everyone. It's important for NASA. It's important for the future of human spaceflight. It's important for commerce in space, and so it's certainly a positive thing. So we are very much supportive of this activity. What we need to be careful about, or from a NASA perspective, is we understand the risk. And so we get to decide the risk level that we will accept, and we're doing that. SpaceX has been very cooperative with us and answering all our questions and sharing data with us, and we've even had people participate in some of the testing. So I think the effort that's going on between NASA and SpaceX is excellent with respect to reuse, and we certainly see that as an avenue for reduced costs in the future.
Great. Additional questions in the room, the front row, please.
Chris Gebhardt with NASA Spaceflight. I'm wondering for Kirk and maybe Jessica, if you could talk a little bit more about the decision for the flight-proven booster. When was that decision made? It was only confirmed last week, so I'm wondering, was there a contingency plan to use a new core if NASA had decided not to use the reflown booster? And also, what's the precise launch time tomorrow down to the second?
So I guess I can start with that one. So we've been working with NASA since January of this year on the process for ensuring that a flight-proven booster is of equivalent risk to a new booster. And so, like Kirk mentioned, yeah, we've been having technical meetings with NASA for each different group. So, for example, dynamics on the vehicle, propulsion, avionics, each of those different groups have been meeting with their NASA counterparts for several months. So we've been working at this for many, many months. And as we get closer to the launch date, the way it works, as you know, we can have turnaround times of roughly 2 weeks. So, about 2 weeks before launch is the absolute drop dead of generally when a decision needs to be made to not impact the launch date. I forgot what was the second question you asked? Precise launch time. 11:46 a.m. I'm going to guess 13 seconds, but that's a total guess.
We can follow up with you, Chris, and get you that.
Yeah.
Let's see, I wanted to add to that if I could. By the way, I'm not going to add to the 13 seconds. So it is important, but I don't know the number. But in terms of reusability, we absolutely have. What I described earlier, NASA went off on their own and said, hey, if we were going to fly a Falcon 9, reuse a Falcon 9, what would we like to see in terms of analysis, testing, inspection between the flights, and so on? And so we did that. We laid it out ourselves independently. We then met with SpaceX and went through their data and their certification package. We put on some constraints, by the way, I didn't mention earlier. We've agreed to a single reflight, and at this point we've agreed to a single reflight of a booster that was flown to a I'll say a benign mission like ours, like a CRS-1 flight. So we only agreed to a single reflight, and in a low Earth orbit mission has to be the flight for the first attempt, for the first launch. The reason the decision was made so finally is like we said, there's the general certification, then there's actually the inspection of the booster, and then finally there is actually a review conducted by SpaceX, a reflight readiness review. Think of it as basically a flight readiness review for that particular booster. And so NASA was part of the certification, the generic certification. NASA reviewed the inspection plan in between the flights, and we were waiting and finally for that reflight readiness review to be complete, to go over all the issues and make sure at that point we were still comfortable with the risk level for this flight. And that's why the actual official decision, a letter that we sent, a contract letter to SpaceX here, I think a week and a half ago, 2 Wednesdays ago, if I'm not mistaken, but I can look that up if you need it, but very, very recently. At some point in time, we knew that there would be a change. We told SpaceX that we were heading down this path, but we weren't ready to commit until that final reflight readiness review was conducted, and that we understood that if we changed position, if we changed paths and used a new booster, it might affect the launch date. And SpaceX understood, and we were partnering all along. So we were waiting till that final decision, that final reflight readiness review, and then NASA decided and sent the letter.
And a question from the back of the room, please.
Hi, Stephen Clark from Spaceflight Now. One for Jessica. Specifically for this booster, do you know if all 9 engines, I'm curious, on this booster were from the CRS-11 mission, or did you swap any out? And for Kirk Shireman, in your preview of 2018, you mentioned commercial crew perhaps arriving at the station late next year. Can you give me an idea of your confidence in that schedule right now? And are you looking at going off and buying more Soyuz seats from Russia for 2019 as a hedge against that? Can you update me on that contracting situation with Russia and your confidence in commercial crew arriving next year? Thanks.
So all 9 engines on this booster did fly on the CRS-11 mission. We did not have to replace any of them.
Wow, I wish my answer was that easy. The fact is, flying into space is very difficult. Flying humans into space is even more difficult. And so, as we have seen, the dates for both SpaceX and for Boeing have slipped to the right. It's not unexpected. We knew that this was likely to occur, and we have dates now, and we are planning for those dates to slip, or certainly being prepared for those dates to slip, I would say it that way. They'll fly when they're ready, and while we want them to be ready as soon as possible, we also don't want them to fly until they are ready. So we are trying to build flexibility to the International Space Station program so that we can allow the commercial crew program the time that they need to fly successfully. We are not in discussions today with Russia with respect to additional flights. As you know, we actually in January of this year, we signed a deal with the Boeing Corporation, but it actually involved, of course, Soyuz flights. It allowed us to fly Joe Acaba, who's on orbit today. It'll allow us to fly Ricky Arnold in March of next year. And it also allowed us an option to fly 3 U.S. astronauts in the first half of 2019. In October of this year, we exercised that option, so we have seats to fly U.S. astronauts on Soyuz vehicles through the first half of 19, which means they'll land in the second half of 2019. We are still thinking about ways to buy additional margin if we have to. Various options. There's a whole spectrum of options that we are considering. But our confidence in the launch dates for SpaceX and for Boeing and their commercial crew vehicles is increasing as well. So I'll say we're going to look for options until the first rotation flight, because that's our job, is to be prepared for contingencies. But I think we are absolutely progressing, and look forward to demo flights in 2018.
And it looks like we have a couple of questions online, so we'll take a question from Jason.
The first question here comes from Twitter user Edna, who asks, how many experiments on the Dragon cargo craft are going to be delivered to space station?
I guess that's for me. Total number, I'd have to check into. Literally dozens of experiments are going up. They add to the total for the increment, which is 329. And 75 of those experiments are new for the increment. We rely on SpaceX to provide a lot of our biological research capability, not only because we get the investigations up, but we can get the samples back down as well. So it's an incredibly important mission for us.
Second question.
All right. And then Twitter user Mermal asks, when you bring and take stuff to and from the space station, does an addition or reduction of mass affect the orbit of the space station?
I'll take that one. So actually, from a physics standpoint, the answer is yes. But at this point in time, the space station weighs close to 1 million pounds. And so the change in mass is not a huge difference. So we typically do not see a drastic change in the orbit of the space station from vehicles coming and leaving. So we monitor it all the time, and of course we have ballistics people who plan these things so that it's incredibly complex, by the way, to even intercept the ISS. So when the Dragon launches tomorrow, it starts from a velocity of 0. By the time it gets into orbit, in the ISS orbit, it's traveling 17,500 miles an hour, and it has to catch another vehicle that's traveling 17,500 miles an hour, and that's no small feat either. So anyway, the ballistics teams plan for these things, and because we plan for it, it's not a very significant effect at all.
Thank you, and we'll take a few more questions from the room, right here up front.
Daryl Nail with Fox 35 in Orlando. Question for Jessica. Can you go back to when the launch pad was destroyed? How significantly was it destroyed? What made it through? And in the rebuilding of it, you mentioned it's more high tech. Can you kind of go into some details of what's different about this pad, and when people watch it tomorrow, will they see any discernible differences between it and the one that you rebuilt, and what were the big challenges in rebuilding this pad?
Yeah, so one of the things you'll see that is now similar to what we have at pad 39A is right before liftoff, the strong back is going to quickly throw back just as it does on 39A. So that's one of the upgrades we made. As for the remaining details of everything we had to rebuild, John Murator gave a talk a couple days ago to the press, so you can get a bunch of additional information from that or follow up with our communications team. I'm primarily focused on the Dragon mission, the Falcon mission, but they can give you a lot more information as the launch pad director, gave a bunch of information the other day on that.
Great. Next question.
So Bill Jellin from We Report Space. If the launch slips one day to Wednesday, what will the change in launch time be? Is it 4 minutes?
About 20 minutes earlier.
20 minutes earlier.
Yep.
And then the throwback, how long before ignition does the throwback actually start? Do you know that?
On 39A, I think it's the same. We would come back a little bit, about a few minutes before, and then it's just seconds before that it throws back all the way.
And here on the right side.
Jim Siegel, Spaceflight Insider. I'm particularly interested in the issue of looking at space debris. And so I understand that the space station has some sort of shielding that protects it to some extent from small particles or whatever. I wonder if you could talk a little bit about that. And also, I understand that the space station has a capability of maneuvering out of the way of larger pieces that might come in proximity to the space station. I wonder how many times that's been done since the space station has been up. Thank you.
Okay, I'll take that one. So the space station, because it lives its life in low Earth orbit, and if you're interested in the debris environment in low Earth orbit, we can point you to some resources there. But the debris environment in low Earth orbit is quite significant. So we designed it with the requirement to live in that environment. And basically it has shielding. It's really very clever shielding, but the shielding on board the International Space Station can handle everything less than about a 2.5 centimeter particle. So any debris that's less than 2.5 centimeters, the shielding will take care of. Anything greater than 10 centimeters is actually tracked. So things that are larger than that, the sensors that are here on the Earth will track it, and those guys, the guys who operate those sensors, will tell us, and we'll actually try to maneuver the space station away from that debris. So that's the kind of environment. And if you can picture the teeny tiny, think of grains of sand, is the largest number of particles are about that size, paint flecks, those kinds of things. The larger debris is much, much smaller. In fact, it's an exponential curve. So the good news is we are vulnerable. The risk that we take every day, every minute, every second on board ISS is the difference between a 2.5 centimeter particle and a 10 centimeter particle. That risk is in a regime where there aren't that many pieces of space debris out there. The ones that are larger we track and get out of the way of, and the ones that are smaller where the shielding protects us. In terms of the number of debris avoidance maneuvers we've executed over the years, I don't have that number. Actually, 23. Okay, I phoned a friend, so I'm told 23. So that's actually not that bad. 23 over, and we launched, the first piece was launched November 20th, 1998. So in 19 years, 23 maneuvers. I can tell you, though, we get notifications because it's not just that the particle is that size. What we're doing is predicting it into the future. So these things are all going really, really fast around the Earth, and even our knowledge of these orbits these things are in is uncertain. I'll say there's some error bars around it, and so we get notifications when something's going to come close. So we actually plan a larger number than that. I would say we probably plan on the order of, I don't know, 6 to 12 a year, what we call debris avoidance alerts. So we'll start planning those, but before we actually have to execute them, the predictions firm up and we don't have to execute them. So space debris is a significant issue. It will continue to be a significant issue. And this experiment we're flying on this mission is a really important experiment. It'll help us gather some additional data and be smarter not only for ISS, but for future human spaceflight and for even commercial spaceflight into low Earth orbit.
Question here.
Hi, Elsa Conessa for the French paper Les Echos. I was wondering if you could give us some a rough idea of the cost of the mission and how it compares to other launches.
Unfortunately, that's proprietary information, so I'm unable to disclose that. There is some information about the total cost of the contract that you can find out in the public, but unfortunately, I can't go into the details of the pricing of each mission.
Glasby with WFIT, you were describing some of the science that is flying, and some of that is for commercial companies like Budweiser and Made in Space. Are they charged to fly their science up, or is it free?
So to talk about any of that, I'd have to defer to the National Laboratory who actually handles those contracts. In most cases, though, what the ISS provides is the transportation to and from the space station if it's required. The agreement to fly and how that's funded either through CASIS grants or as other governmental agencies sponsoring research. For instance, we've had National Institute of Health and NSF sponsor research in the past. Those types of grants can be involved as well. So for commercial entities, it is a possibility that they're paying their own way, and it's also possible that they're supported in part by grants. But that's a question that I'd have to refer you to CASIS and the National Lab manager to go ahead and answer that.
Left side here.
Hi, I'm Jessica from CNBC. My question is for Jessica. I'm wondering where Elon plans to watch the launch from.
Ooh, that is a great question. I'll have to follow up with our team. I don't exactly know where he'll be. You guys know? Hawthorne? Yeah. He won't be, we don't think he's going to be in Florida, so he's probably going to be watching from our headquarters in Hawthorne. We have a very large, for every launch, we have a very large gathering where the whole company comes out and watches every single launch.
Follow-up question from Irene?
Thanks. Irene Klotz with Aviation Week. For Jessica, has SpaceX resolved the payload fairing data review issue to allow the Iridium launch later this month?
Yes, so we have the Iridium launch scheduled for no earlier than December 22nd. That will be launching out of Vandenberg Air Force Base. And then we also have the Zuma mission launching in early January of this year, or of next year.
And a few follow-up questions from Marcia, please.
Marcia Dunn, Associated Press for Jessica. Over at Pad 39A, how's it shaping up for the test firing for the Heavy, and do you have a date for that yet?
So it's progress is moving great along. Yeah, so we're getting it ready for the first Falcon Heavy static fire. So the static fire is targeted to happen before the end of this year, and then the launch will happen about a few weeks after that.
So the delay for this didn't impact that? Oh, I'm sorry. The delay for this launch, did that impact all that work?
Nope, we did have some, we do have some shared resources, but final activation of the launch pad is a little bit different than the work we had to do for 39A to get it ready for the 3 boosters.
If I could have one more follow-up for Heavy. I was wondering if you could address any of the roadblocks, pun intended, that you may be dealing with to fly a Tesla into space.
So I will just say that we are following all regulations. So, it's still, these are still licensed launches, so we still follow all the rules that we need to follow launching out of Kennedy Space Center. We follow all FAA regulations, FCC. So we are following all the regulations, including for the Roadster.
We'll take a couple more follow-up questions. So Chris and then James.
Yeah, Chris Gebhardt with NASA Spaceflight. 2 real quick. So Jessica, you mentioned earlier the test firings of the booster stages out in Texas. Do all the reflown boosters still go to Texas to be refired between launches, or are those tests taken care of during their static fires for their reflights? And I believe for Kirk, for the rendezvous plan, am I correct that launching Tuesday, berthing Friday is to deconflict with the Soyuz undock on Thursday? And if we slip to Wednesday for the launch, is berthing still Friday, or does it move to Saturday? Thank you.
So I can start. So what we do now is when we get boosters back and we start refurbishing them, we do not have to send them back to Texas for the test firing. We want to do that before an initial flight to make sure that it is ready to go. But like I said, then, that's basically what is called an acceptance test, which is a workmanship test of the entire vehicle as it's built up. So once we verify that's all good, it goes for its first flight. Again, that really confirms that it has been built properly. So then when it comes back down, all we do is the static fire test at the launch pad before it flies again. I will tell you one of the reasons for the 3-day phasing to the space station is just orbital mechanics. Simply, the space station, where it's flying closest to Florida tomorrow is just a little bit further away than normal, so it's going to take about 3 days to get there.
Yeah, so Jessica's right. The berthing date is driven by orbital mechanics. We did not defer the berthing date. In fact, I can say we track that. We're very, very concerned about berthing dates because we fly biological samples that have to be maintained at a specific temperature level, and really it's a race from the time we load those onto the vehicle, less than 24 hours before launch, until the crew can offload them on board the space station and put them in the right place. We track that time and we plan for contingencies, and we watch that very, very closely. So we're not deferring anything to allow berthing days. We do prohibit launch on certain days. So in fact, the reason it's the 12th and the 13th and not the 11th is because of that. So the 12th and 13th actually put us berthing, the 12th puts us berthing the day after the undock, so on the 15th. And if we launch on the 13th, I believe we're berthing on the 16th. And if you ask me on the 15th, I think the 15th we berth on the 17th. So you can see the number of days between launch and berthing changes, and it really has to do with this orbital mechanics and really in a circular orbit where the ISS is relative to the Dragon when it's inserted into orbit. That distance, or that angular distance, is what really drives those dates. And right now what we do is we allow the vehicle to launch to avoid constraints as opposed to managing those once they're on orbit.
Final question in the room, please.
Jim Siegel, Spaceflight Insider again. Have a question for Jessica about the Dragon capsules. How many different Dragons are there? Have any been retired yet for whatever reason? And when you retire one, do you just go out and build another one?
Yeah, so man, I have to think of how many we have. I think we have, about 7-ish in our fleet. Some of the initial ones we flew, a lot of those components or those vehicles we're only going to fly one time. One of the biggest things we did starting on roughly the CRS-8 mission was we significantly increased the water sealing capability of the vehicle. And that allowed for a much easier refurbishment process from flight to flight. So that was one of the big things we did. So yeah, I can't remember the exact number of vehicles we have, but we do have several of them. I'm sorry, what was the second part of your question?
So when one is retired for whatever reason, do you just go out and build another one? And you do that internally, I believe, right? So
Right. So what we do is each Dragon currently goes back to our McGregor test facility in Texas. And what we do is we can look at the whole the vehicle as a whole and see if that entire vehicle can refly again, based on the service lifetime it is qualified for and all the environments it was exposed to during that particular mission. Or we can also save the vehicles there, and then we might be able to refly things such as the propellant tanks, the batteries, the flight computer. So certain missions may need a spare hardware because, it's reached the service life on a different mission. So we can either refly entire capsules or we can actually refly hardware from previous vehicles. You're welcome.
And we have one last question from online.
This question comes from Twitter user Adrian, who asks, how close are we to seeing reusability of the second stage of the Falcon 9?
So I would say that is not currently a priority right now. I would never throw that totally away, but yeah, I would just say that is not a priority right now.
All right, and with that, we're going to wrap up today's pre-launch news conference. Kurt gave us a great overview of the science to come, but if you're available, please join us live on December 11th at 3:30 p.m. Eastern for a broadcast of What's on Board, our science overview. Thank you to all of our speakers. Thank you for everyone for joining us today, and have a wonderful day.